Hello, beautiful people, and welcome. In this video, we will be reviewing our quadratic equations and complex numbers. So in this video, we are solving quadratic equations. These will include having complex numbers as answers. And then we're also going to be adding, subtracting, multiplying complex numbers, and perhaps using conjugates to divide complex numbers. Let's go ahead and get started. When completing the square, you want to remove that constant from the equation side. So I'm going to add 13 to both sides. Negative x squared plus 4x is equal to 13. Now, notice that you have a negative 1 out in front, this one here. When completing the square, your first leading coefficient has to be a positive 1. In this case, because we have a negative, that means we have a negative 1 in front. So we will have to divide everything by a negative 1 in order to remove that negative from x squared. What we are left with is x squared minus 4x is equal to a negative 13. Moving on with completing the square, you're going to take this middle term. You're going to divide by 2 always. So that is negative 2. Now take that answer, that product, you're going to square it. So I have negative 2 squared. Now that product, that answer, in this case it is 4, you're going to bring it up. I'm going to shift this paper up. You're going to bring this one here up to both sides of the equation. And you're going to add that to both sides. So I'm going to add 4 to both sides. So what you end up with, I'm going to bring this up. What you end up with is x squared minus 4x plus 4 equal to a negative 13 plus 4, which ends up being negative 9. Now, the purpose of completing the square is to get a perfect square binomial. And what that means is you're always going to end up on this side here with a binomial that's been squared. Now, what do you write inside? We're going to write an x for your variable. And then going back to when you first divided by 2, that product, this product of negative 2, that's what you're going to put in here. So you're going to say negative 2 is in here, and that's equal to negative 9. Now, before we had complex numbers, we would say this had no solution because you're going to end up having to take a square root of a negative number. Because we have complex numbers, you can continue to solve. So let's go ahead and take the square root of both sides. Now, when you take the square root, you must include a plus or minus. Here's a secret index of 2. When you take the square root, that 2 is not there. It's just something that mathematicians are too lazy to write, so you don't include it, but it's there. That index of 2 and the exponent of 2, they undo each other, so you're left with x minus 2 is equal to plus or minus the square root of negative 9. Now, the square root of negative 9, you can do it 2 different ways. You can either do that right now, or you can wait until after you add 2. I'm going to choose to do this now. I'm going to split this up into 2 things. I'm going to split it up into negative 1 times the square root of negative 9. However, we also note that, positive because I removed the negative. And we also know that the square root of 9 is just 3. We also note that the square root of negative 1 is the imaginary unit I. So this is I times 3 or 3 times I. So what we are left with is x minus 2 is equal to, and I'm going to try to box this off here, is equal to 3i. Now don't forget you have this plus or minus still in front. Now you can add 2 to both sides. So you have x is equal to 2 plus or minus 3i. Now your answer must be in this format where you have your real number 2 in front and you have your imaginary, your complex here, in this case 3 attached to I. Now the plus and minus is in between because we're adding 3i and we're subtracting 3i. So that's why it's in the middle and not in the front. Moving on to the quadratic formula, you must have the quadratic formula memorized at this point in my class. So just in case you don't, let's write it out one more time. We have x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Now this one here is obviously not in standard form, so we're going to convert that to standard form. So I have 3x squared minus 6x plus 1. And how did I do that? I subtracted 6 here and I added 1 to both sides. So this is our equation. Identifying our ABCs, here's your A, here's your B with the negative, here's your C. So A is 3, B is negative 6, C is 1. Let's plug that into our equation. So I really do like to use bubbles when you're substituting in values because sometimes if you get two negatives, it's easy to forget you have two negatives if you don't see it. So okay, so B, our value of B is negative 6. Our value for A is 3. Our value for C is 1. And our value for A is 3. Let's rewrite the formula. We have 6 positive because two negatives make a positive, plus or minus the square root of 36 minus 4 times 3 times 1, that's 12, divided by 6. Now, if we recall the discriminant, 36 minus 12 is 24. If you recall the discriminant tells you how many solutions you're going to have, how many real solutions you're going to have. Now, because our inside here is 24, that means that yes, we will have a real solution. This will not include any sort of imaginary numbers like I. However, it might not be pretty because 24 is not a perfect square. It's not a perfect square. So 25 is a perfect square, but 24 is not. So it's not going to be pretty, but at least it's not going to have any imaginary numbers in it. So let's go ahead and you can factor this out. So let's use the product property to say what two numbers multiply to get 24, that at least one of them is a perfect square. So I'm thinking 4 and 6. 4 times 6 is 24. And I can take the square root of 4. I'm going to shift this over here. I'm going to bring the paper up just a little bit higher so you guys can see. So I have 6 plus or minus 2, because the square root of 4 is 2, times the square root of 6 divided by 6. And that's equal to, and I'm going to split this up. So I'm going to say 6 divided by 6 plus or minus 2 divided by 6, and then you have your square root of 6. Now be extremely careful. Don't start crossing things out. Don't do it. This root 6 cannot be combined with anything else. This root 6 and this 6 in the denominator are completely different. One of them is a radical, the other one is a number. That is not a radical. So different stuff cannot combine. However, this one, 6 divided by 6, we know that. We can do 1 plus or minus. We can also simplify these numerics into 1/3. And then we have our radical 6. Now again, you can do this one more time and say 1 plus or minus root 6 divided by 3 as your final answer. Moving on, we're now going to be taking the square root. Taking the square root seems to be everyone's favorite. You're going to get your variable by itself. In this case, it is attached to a 2. So I'm going to remove 5 first by adding 5 to both sides. I have 2x squared is equal to negative 55 plus 5. That's equal to a negative 50. I'm going to now divide by 2. Get my dotted line here so I don't mess up on my sides. So I have x squared is equal to negative 50 divided by 2. It's like having 2 quarters or not having 2 quarters since it's negative. That's 25. Taking the square root of both sides. Make sure don't forget your plus or minus when you're taking the square root. Again, here's a secret index of 2. Those go away. X is equal to plus or minus the square root of negative 25. Now again, make sure to split those up using the product property. You have a negative, let's do square root of a negative 1 times the square root of 25. Well, you already know that the square root of negative 1 is equal to the imaginary unit I. And you know that the square root of 25 is equal to 5. Make sure you write this in the correct format. Very important you write this in the correct format. So you have x is equal to plus or minus. We don't have any real numbers, so we have 5i as our answer. Next up, we are going to be adding, subtracting complex numbers. Now, when you're adding, subtracting complex numbers, you can treat I as a variable, and that pretty much sums up how you add and subtract. You're combining like terms. When I see a negative like this, a minus, you're going to distribute that minus into the one to the right. So the minus belongs to the following bubble or the following grouping. So I'm going to rewrite this. I have 7 plus 2i and 1 plus, 1 minus 4i. Now I'm going to change this one into a plus because I'm going to change all of the other numbers into opposites. So this one's going to be a positive 13. This one's going to be a positive I. I have distributed that negative. Now that I've distributed my negative, I'm going to combine like terms. So I have a 7, I have a positive 1, and a positive 13. I have 2 i's minus 4 i's less 1 I. You can choose to write this all like grouped together. For example, 7 plus 1 plus 13, and then plus 2i minus 4i plus I. And then you can group them like this and add and get your final answer. So I have 7 plus 1 plus 13, that's 21, plus, and now I have 2 i's minus 4 i's plus 1 I, and that gives me a negative 1 I. Now in this case here, you're not going to write plus a negative. You're always going to just use either plus or minus. So in this case, 21 minus 1i, you can choose to put a 1 in front of I. However, that is not needed, and that is your simplified answer. Moving on to example number 5. In this example, we are multiplying by a monomial. So you're going to distribute. You're going to take all of this and you're going to multiply inside. Now, how do you multiply? You're going to multiply things that are the same together. For example, I have negative 3 times I times 7 times I. And then I have a negative times a negative, so it's going to be a positive. So this negative and this negative create a positive. And that's going to be 3 times I times 5. And I'm going to highlight this in 2 different colors so you know what we're talking about. We're talking about the first multiplication, and then we have the second multiplication. Now these two, the yellow and the pink, are separated by addition. So everything in yellow gets multiplied, everything in pink gets multiplied. So what are we multiplying in yellow? You are going to multiply the numbers together, and then you're going to multiply the I together. Same thing here. You're going to multiply the numbers together, and then you have this I that's kind of random. Negative 3 times 7 is negative 21. I times I, negative 21. You see that? My 1 became an I. So negative 21, then you have I squared, plus 3 times 5 is 15, and then you have your I. Now, I squared has a meaning. I squared is equal to negative 1. So this right here in a bubble is super important to have a bubble. So you do not think this is subtraction. This is in fact multiplication. So this is negative 1 times negative 21, which equals to positive 21, and then you have your plus 15i. So 21 is the real portion, 15 is the imaginary portion because it is attached to the letter I. Let's do one more example. This one here is asking you to square. So when you have an exponent, make sure that you expand by writing it out that many times. So if my exponent was 3, I would write this out 3 times. If my exponent is 4, I would write this out 4 times. I'm very happy my exponent is 2 because I only need to write this twice. Now you can choose to FOIL if you want. I encourage my students to write this as a box method just because it's easier to track your numerics. It's easier to keep everything in a bubble, in groupings, in boxes. 2 times 2 is 4. 2 times 3 times I, that is 6i. Again, multiply the numbers together, multiply the i's together. 3 times 2 times I, once again, multiply the numbers together, multiply the i's together. And then we have 3 times I times 3 times I. So that means 3 and 3 is 9. I and I is I squared. We know what I squared is. I squared is equal to a negative 1. So you have 9 times negative 1, which means that the answer for this box right here only is negative 9. So let's go ahead and simplify this. Let's simplify this down below and then bring our final answer up. So I have 4 plus 6i plus, gotta have a little tail, 6i minus 9. So notice that you're going to have real things like 4 and negative 9. And then you're going to have imaginary, which is your 6 and 6. So just like we did in example number 4, when you're adding, we're going to add the quantity of i's. So if I have 6 i's and I have 6 more i's, how many i's do I have? I have 12 i's. Now, to me, anytime I say I think of eyeballs. So I have 12 eyeballs. I have 12 eyes. I now have 4 minus 9, which is negative 5. Again, make sure that you bring your not numeric, make sure you bring your real number. I hesitated there for a moment. Make sure you bring your real number up front. Don't put it behind. So let's go ahead and write out our final answer. Final answer for this is negative 5 plus 12i. All right, beautiful people, let's go ahead and move on to 2 more, and then I'm going to wrap up this video. This one here is asking for you to divide. How do you know it's asking for you to divide? Because it has a division symbol, which is this one here. Unfortunately, with complex numbers, we cannot divide, so we have to multiply by the conjugate. The conjugate is the exact same thing as the denominator, which is 4 and 3i. However, the middle symbol, and only the middle symbol, is what's different. So because I had a plus here, the symbol is going to be a minus. That means that 4 plus 3i and 4 minus 3i, those are considered conjugates. Now, when you multiply them, the bottom follows a pattern. The bottom follows a squared minus b squared pattern. This comes from the square binomials, right? So when we have this, we can, I'm not going to worry about the numerator here. We can say, what's our a? Well, our a is 4 squared minus, always minus, don't change the minus. What's our b? Well, our b is 3i squared. For the numerator has a binomial times a binomial. Okay, we'll write it out. 3 minus 4i times 4 minus 3i. The numerator does not have any sort of pattern. You will have to use the box method or the FOIL method to multiply all of this out. But let's talk about the denominator one more time. 4 squared is 16 minus, now this 3i squared means, I'm going to put this in brackets so it's separated, 3 times I times 3 times I. That means you have 3 times I twice. And just like we saw in example 5, anytime you are multiplying, you multiply the numbers together and you multiply the i's together. So what you end up having in the numerator, in the denominator, the one in the bottom, is, and I'm going to keep it in brackets again just to separate it, you have 3 times 3 and you have I times I. Well, 3 times 3, you guys know what that is. 3 times 3 is 9. I times I is I squared. And again, you know what I squared means. I squared is a negative 1. So that means you have 9 times negative 1. Let's go ahead and simplify the denominator one more time. You have 9, you have 16, I can save it. 16 minus a negative 9 in the denominator. 2 negatives make a positive. So you have 16 plus 9, and that gives you 25. Now for the numerator, let's back up here for the numerator. For the numerator, you're going to have to use the box method. You can use it down here. And you're going to have 3 minus 4i times 4 minus 3i. 4 times 3 is 12. Negative 4 times 4, that's negative 16i. 3 times 3 is 9i. Negative 4 times 3, that's negative 12. I times I is I squared. So that means here in this bottom, you have negative 12 times negative 1, which is a positive 12. So in the numerator, trying to find a perfect color for that. In the numerator, we have 12 minus 16i plus 9i plus 12. And then we're going to combine the 12s. So you have 12 plus 12, which is 24. And then we're going to combine the middle terms, which is negative 16 plus 9. Why do we combine the middle terms? Because both of them have an I, so I can combine them. So we are left with 24 minus 7i, and again, 24 minus 7i, because you can't simplify the numerator further. So here is your simplified answer. This is your answer. Let's do one more example. This example is asking you to evaluate. So this is not to simplify. This is to evaluate for a numerical value. That means anytime you see x, you're going to write a bubble. So I have x squared, here's your x, minus plus, just kidding, plus 11, 3 minus x. And instead of writing x now, you're going to write 4i. So here's my 4i, and here's my 4i. In the numerator, you have 4 times I, and you have 4 times I, so you have it twice because of the exponent of 2. You still have this plus 11. In the denominator, you can't really do anything because you have a real portion, 3, and you have an imaginary portion, 4i. So let's work with our numerator. Numerator, we have 4 times 4, and we have I times I. So 4 times 4 is 16. I times I is I squared. And then we have our plus 11. Don't do anything with the plus 11 just yet. I'm just going to rewrite the denominator. Oh, you guys can't see that. I apologize. Don't do anything with the 11. I squared, we know that that's equal to negative 1. So you have 16 times negative 1. Still putting that in a bracket just so it's separate from the 11. And the denominator is done. There's nothing for us to do with it. That's why I keep copying it down. I have negative 16 plus 11. Now I get to deal with that 11. So negative 16 plus 11 is a negative 5. Denominator stays the same as it has. And here's your simplified answer. All right, beautiful people, thank you so much for watching this video, and I will see you in the next one. Bye, have a great day.